Yep, thank you. Today I'm Anders Potgieter. I'm in the Crop Science Center for Crop Science at QAAFI at University of Queensland at Gatton. And today we also at this moment we want to acknowledge the traditional owners and their custodians of the lands on which we meet. We pay our respect to their ancestors and their descendants who continue cultural and spiritual connections to the country. We also recognize their valuable contributions to Australian and global society. Just for some housekeeping things to start off with, the seminar is scheduled for 12 noon until 1 precisely. At the conclusion of the seminar, we will hold a Q&A, short Q&A session, and if you have questions that you would like to answer, please use the Q&A button at the bottom of the presentation slides. Is a Q&A. Don't use the chat icon. Click on the Q&A button. Then I just want to, without further ado, introduce Dr. Joe Eyre. Dr. Joe Eyre did his PhD at UQ around 2010, I think, Joe, if I'm correct, and is currently a research fellow in Crop Science, Center for Crop Science, with more than 12 years of experience in mainly agronomy, farming systems, co-designing of systems. This includes co-designing of cropping systems with farmers, agribusinesses, and multidisciplinary research teams across northeastern Australia and sub-Saharan Africa. I think there's a few years that Joe and his family also lived in Africa. So he has the vast experience of cropping systems in various countries across the globe. He currently leads the new and exciting project, which this seminar talk is all about, and I'm sure he's going to tell us more about it. This is funded by the CRC for Northern Australia, and the project title is North Queensland Cotton Grains Cattle Farming Systems. It's also GRDC funded. He also had a GRDC funded, currently lead the GRDC funded project, which is established Australian economic management thresholds for fall armyworm in maize, rainfed and irrigated and sorghum projects. At this stage, Joe, please go ahead.
Yeah, so I guess I'll start now. I'd like to, first of all, thank Andres and thank everyone for joining us today. I'm very excited here to share with you a bit of awareness of a new project we're starting. It involves research in far north Queensland, and it is part of a larger project that will kick off towards the end of this month. I'm acknowledging only the theme leaders here. There is a lot of people involved in this project, and I'll acknowledge them as we go along. The project is part of the CRC-NA Developing Northern Australia, with co-funding from GRDC and CRDC in partnership with University of Queensland, DAF, CQ University, Gulf Savannah NRM, and industry partners including Radical Seeds Australia, AgriMix, and Far North Queensland Sustainable Cropping Group, as well as some other participating farmers. So just to acknowledge that what we're talking about is developing farming systems for Northern Australia. And we know that this is not a new idea, that there's been a lot of concerted efforts to develop farming in Northern Australia, more intensive farming, that is. There's also already existing very well-established beef industry. However, even at Federation, Edward Barton announced a push to develop cropping in far North Queensland. And there's been continued efforts regularly to new developments. The one thing that has been done has been reviewing these failed schemes. And what there seems to be is this, across all of those reviews, there is a consistent message that there is a lack of unified vision for that development that is limiting or the research efforts, the industry efforts to overcome the challenges that exist. And even still, when we go and we talk to stakeholders in North Queensland, they acknowledge those same issues of developments coming from external and being complete packages and not taking the whole of the community with them. And that has implications for the institutions and actually developing local businesses that can support those developments through difficult times or to change. So what we are looking at in this project is to identify cash crops that justify development of farming system of farms to crop. Those cash crops at the moment are, the focus is cotton, and it is believed that the profitability of cotton is sufficient to justify that farm development into a cropping enterprise to support diversification of farms in North Queensland. This needs to be part of a sustainable crop rotation with high biomass cereals such as sorghum, and linking that to the existing profitable beef businesses. So our project vision is for farmers, research and agribusiness to co-design, test and adopt scalable farm diversification and drought resilient practices and options with improved economic, social and environmental outcomes for rural communities in North Queensland. As I've discussed, there's been a number of drivers for this change over the years. Currently, high commodity prices and land prices for farmland in Southern Australia are driving interest for cropping in Northern Australia. Market risk around large export markets for the existing cattle business, as well as biosecurity risks such as lumpy skin, mean that there is need for those beef systems to have agility to change if those markets change. Also, existing climate variability. We know that Northern Queensland is we're talking about Northwest Queensland, semi-arid tropics, where the climate variability is extreme. So what we are doing in this project is in North Queensland, we're working with those lead farmers that are already established very diverse systems. We need them to be part of this co-design and participatory action research. We've worked with those farmers to identify what their needs are to take the next step in their sustainability of their business. Those growers have identified that cotton has issues about how to more sustainably grow cotton and reliably grow cotton, where we have unique pest and disease issues that occur in the humid monsoon period. Also to look at cropping rotations that fit that cotton's pinnacle crop, to make sure that we utilise the we get the best utilisation of the rainfall that does fall. Also to investigate opportunities for increasing income from new funding sources like ecosystem services. But by and large, any of those new systems need to fit into the existing cattle system that dominates North Queensland. That includes the production of cattle and opportunities for utilising outputs from the cropping system in that cattle system. So that could be drought feeding, that could be maintaining weight through the dry season to get the calves off in time, weaners off, or get cows back up into weight. So in the first year that we're just about to start, we'll be working with those lead farmers to address those questions that they have around their system. We'll be characterising their farms and engaging them in their own research to understand and enhance the existing systems. We'll also be evaluating the existing sustainability frameworks that have been developed for commodities in that are mainly Southern Australian focused, as well as developing whole farm economic models to understand how our interventions can impact the profitability at the farm level. Once that relationship is established, we intend to work in a co-design process with support of cropping systems models to start to identify where the farmers want to be in the future and the opportunities they see to diversify and to increase the drought resilience of their whole farm. In the second year, those farmers will be invited to test those diversification options on their own farm, in livestock, in case study farms that are on a continuum from specialist cotton producers through to more generic cotton cropping farms, right through to mixed farms and livestock specialists that may utilise the local production of crop outputs in their beef business rather than something produced on their own farm. To give you some idea of the scale of the developments in North Queensland and the logistical challenges, what we've seen here is we have a map of the existing northern region and the cropping area that's highlighted in yellow. In addition to that, we have some focus farmers that we've been dealing with, and we've got some that are in that northern range region. So the lowest point there is the Emerald Smart Cropping System, the Central Queensland Smart Cropping Centre. It was formerly known as the Emerald Agricultural College. We're also working with producers that are really pushing the northern margins of the northern cropping region. Right up to a group of growers on the western slopes of the Atherton Tablelands. More groups of growers that are in the Gilbert catchment area. Some farmers in the lower Flinders River area, as well as the upper Flinders. So this is around Richmond. So what you can see is that the distance between these regions is comparable to the distance across the entire established Northern Range region. That's important to note that we don't believe, and the Australian government also believes that this development needs to occur in a mosaic. So we don't expect large tracts of cropping instead, what we expect to see is smaller cropping enterprises spread across this large area as the way that cropping will expand into Northern Australia. So we have a aspirational goal to work with those case study farmers spread across these regions that will be the focal point for all of our research. Across the themes of this project, individual farmers within those hubs will work with specific research questions. But together with regional farming community groups, we will be identifying those problems and developing solutions together. Testing those solutions on case study farms with the aid of cropping systems models, and the research team will help the farmers to implement and analyse those on-farm trials. So now to go into a bit more of the specific questions, the cotton subsystem research will be led by Paul Grundy from DAF, with Linda Smith and Laurie Owens. There will also be a project officer appointed in North Queensland, and they will be looking at diagnosing and surveilling diseases and pests of cotton in northern humid environments. They will be also looking at demonstrating the existing cropping systems that have been developed by Paul and his team in the Burdekin to demonstrate how managing the crop canopy improves profitability and can be integrated with the pest and disease management. The second theme is led by Graham Harris, with myself and Laurie Owens, and a new appointment also project officer to be based in North Queensland. Here we're extending the work we started in a previous project that looks at how best to capture and utilise rainfall to support crop growth. These pictures here display some of the extremes that we experienced in the first project that we were involved in. What you see on the left-hand side is a sorghum crop that had over 500 mils of in-crop rain, but it fell in such a short, intense period that seals formed on the surface and water only infiltrated to 30 centimetres. Beyond that, the soil was dry and had a very high tensile strength, which limited the ability of the crop roots to explore those deep layers. Almost right beside that plot was a long fallow that the water was able to infiltrate right down into the profile, and we could easily take soil cores to 2.5 metres, and our chemical analysis found no subsoil constraints other than the dryness in our plots. Now, this is a known phenomena of surface sealing across the semi-arid tropics. It's been well defined and solutions are known. What you can often see is these layers of soil that completely block water infiltration. And what that means in practice is that the soil with poor surface structure doesn't infiltrate the water sufficiently. Most of it runs off, risking erosion and carrying with it nutrients and soil organic carbon. If we can improve that soil structure and water goes into the soil, the roots can then explore a much greater area and access more water to protect it during those periods of between rainfall events, so during dry periods. Those initial projects, we were able to simulate those sites, the crop production in those site years. And what we found is those failures were frequent. And unless we protect that surface soil and improve infiltration, the cropping in Northern Australia will continue to be very risky. If we improved infiltration by increasing ground cover, we were able to increase the yields of that from a complete failure to almost 2 tonnes per hectare yield. And that's without increasing nutrients. So at that point, nitrogen became limiting in the system. So what we know is that the most important component is to improve the soil structure, to capture the rainfall, to take us to the next step where we start to approach improving nutrition. Now, in this current project, we intend to work in a participatory research, action research framework to explore how farmers can adapt known technologies for improving infiltration in these environments onto their own farm. Some of the examples here shown are residue retention, micro relief in the surface like basins, deep ripping, contour banking. What we do know with improving soil infiltration is that we require high amounts of biomass to both protect the surface from erosion, to slow the movement of water, and to give it more time to infiltrate, protect the soil from, to provide a home for soil biota that also improve the soil structure and increase infiltration. However, these are often relatively low value cereals that produce that large amount of biomass. What is required is, if we produce those low biomass, if we produce those cereals in North Australia, selling them into existing markets in Southern Australia comes with a very high logistics cost. What we need to do, what we have the opportunity to do, is to improve the value of those cereal crop rotations, either through new local markets like cattle supplement markets. And so again, in the first project, we looked at how those waxy types of sorghum that have a higher value to cattle producers because they are more digestible, how they could fit into the system. What we found was that even those waxy sorghums had a slight yield penalty, the digestible energy that has been estimated from NIR and existing equations actually had those as increased digestible metabolizable energy per hectare compared to the existing red sorghums, like the commercialized red sorghums that you can see here. Now, subsequently, other researchers have identified that there are problems with the quantification of digestible metabolizable energy. So we are going to look at more detail into how these different stresses impact metabolizable energy for the cattle producer. So this research has already started, where we are running trials to characterize the potential grain quality for supplement feeding cattle in a non-stressed environment, to look at how components like grain size interact with the genetic traits of waxy versus non-waxy to improve the quality of grain for animal production. We're collaborating with animal nutritionists who will take these grain samples from our physiology trials to run in vitro quality digestions to establish this metabolizable energy estimate. We'll also match this research with NIR analysis so that we can more quickly and efficiently differentiate grain quality in the marketplace. We'll then use this information to characterize the cropping systems model and identify where and when those combinations of environment and genetics are likely to improve the grain production, the value of that grain production to grain growers and cattle producers across different environments. This will include validation sites run by farmers where they will produce large on-farm strip trials sufficient to run cattle performance trials that will be led by Central Queensland University. In these trials, up to 7 tonnes of research grain will be taken from those on-farm trials and fed to cattle to investigate weight gain, but also look at the impacts on methane production. Finally, this validation will be quantified to do an economic analysis to identify those values, where and when waxy sorghum will be more valuable to grain growers and cattle producers. I've touched on this already, but Central Queensland University, led by Simon Quigley, will be looking at the value of nutrient supplements from the emerging cropping industry in Northern Australia for meeting production targets of cattle, meeting market specifications to de-risk live export, but also open new options for entry of the northern cattle production into southern markets, also for managing at-risk animals. The reason this is important is because traditional supplements are not available, increasingly expensive, and have very variable supply or variability in quality. These opportunities to produce alternative sources of protein and energy on farm represent a new market opportunity for grain production in Northern Australia. Already, subtropical dairy systems have demonstrated many new relevant options for utilising these crops in cattle production systems. This information will be utilised to develop economic models to understand where and when these produce should be produced for cattle producers. That work is being done in collaboration with AgriMix, So this research will not only look at grain, but also legumes. So AgriMix are providing trial sites to produce new combinations of legumes, deep-rooted perennial legumes, to improve productivity of those cattle systems and reduce drought risk. This research will involve pen experiments where Simon will develop dose responses to different tropical forage legumes and potentially whole seed cotton. Also the grain sorghums. So comparing the grain sorghum, the red to white, as well as waxy sorghums, or maybe another option. Here we'll be looking at intake, live weight gain, rumen function, methane emissions, and the economic impacts. With the pen studies, there will be on-farm trial sites run with case study farmers in the second year. These could include things like assisting finishing with grain and grazing legumes. Cross-cutting across all of these on-farm cattle, cotton, and cropping systems themes, we have a program that is looking at establishing a natural resource management sustainability framework and manual. In the first year, Gulf Savannah, who lead this, Zoe Williams and Sarah Stevens, will be evaluating existing sustainability frameworks and applying them to those case study farms, understanding how the fit of those existing frameworks within the northern farming systems and refining how those M&E frameworks should be implemented onto farms and communicate ways that produce a manual to guide producers on how to navigate these ecosystem services. So Sarah has already started a review and identified the existing sustainability frameworks and has already got on board with many of the owners of these, both the sustainability frameworks and best management practices, certification schemes, environmental accounting schemes, and existing markets. Sarah's done baseline surveys of those farms and reviewed those frameworks. And next, in about 2 weeks' time, we'll be going on a immersion tour with those case study farmers, mostly from Far North Queensland Sustainable Cropping Group, to understand the benefits of co-designing a NRM management manual with those members away from their daily routines and experiences to get them to see solutions and imagine solutions beyond their own worldview. This is a very important component of our project, to actually have this connection to the farmers who will be co-investigators in this research and build that legacy of a peer-to-peer learning network through this establishment of the grower group. These on-the-ground research studies will also be incorporated into whole farm models, like the AppSim model and AppsFarm, to evaluate new scenarios that the growers and researchers come up with together, new farm designs, to quantify and discuss the benefits of these simulated alternative designs for the mixed grazing, the grazing and irrigated farm businesses. These farmers will be invited to test those systems on their own farms and evaluate the performance with the researchers. These farmers will also, and regional agronomists, will be offered the opportunity for training workshops in such things as participatory modelling and climate analysis. So this is a bit of a project awareness, and we're very keen to collaborate with anyone interested to work in that area. As I discussed, it's a very large project with many different themes that are working together to tackle some very interesting research problems. Thank you for listening.
Thank you, Joe, for that very insightful overview and making all of us aware of this project. There's about 10 or 15 minutes time for questions and answers. So if you have any questions regarding Joe's presentation or something that's unclear, please type it in the Q&A box on the bottom of the presentation slides or your Zoom window, and Joe can then answer that. I'll start off, Joe, with maybe while people are thinking about a question. You mentioned your tour. What do you have on your grower tour? Can you elaborate a bit on that?
Thanks, Andres. So on the grower tour will be mainly growers from the Far North Queensland Sustainable Cropping Group. So that includes about half a dozen members from that group. But we also have researchers that include myself, Sarah Stevens, and Sid here, who will be developing some questionnaires and to understand the needs of the farmers for engaging in the ecosystem services that are emerging as an important consideration for new farm developments. We'll also be discussing opportunities to improve the cropping system, so looking at ways to manage the soils better to capture rainfall and utilise that rainfall to produce yields. On the tours, we will also include some of the owners of those sustainability frameworks so that they are engaged at the beginning and working with us to embed this somewhat new opportunity in the system.
Thank you. We've got a question online from Graham. Joe, the question is, a priori simulations makes a lot of sense, but how confidently can we model these mixed farming systems?
I think I'll refer you to the group that's led by Daniel, who'll be looking at this interaction between crop and livestock. From my perspective and looking more at the crop scale, I think we have some questions about how we are simulating the infiltration of rainfall. Certainly there's been a lot of work, excellent work done previously, but there is some problems in how that information is being transferred to growers, because the known techniques and practices that improve infiltration are not being utilised. In fact, some of the work done in Catherine in the 80s and 90s, some excellent work that basically very clearly outlined what shouldn't be done, is being repeated right here this season. Things like deep ripping, very aggressive tillage on fragile soils. That's probably where I would like to leave that. Thanks.
Yeah, I think that's how confident in the mixed farming systems modeling of the priori simulations. That will also be very important to actually validate some of those. I would think in these study farms before. A good question from Graham, and there's another question from Sujir. Joe, I understand your point of the importance of infiltration. However, I was a bit confused with the example pictures of the sorghum versus Longfellow. Why was the infiltration better in Longfellow plot than sorghum ones?
The Longfellow area had actually an irrigation over it. It was part of a previous project that's before we started, where water was applied, and there was several seasons to wet up that soil. So the comparison was just to show that if you can get the water into the soil, there is no restriction. That then once the soil surface is protected, to improve the infiltration, the soil can act as a buffer during those dry periods to prevent drought stress.
Yeah.
Thanks, Andrews.
I think Sudhir can also follow up afterwards with you if you need more information, Sudhir. Anonymous attendee, part 1, what are your thoughts about the process farmers need to undertake and consider to prepare their land and understand the mix with their current cattle operations to optimize all operations? That's the first question. So what are your thoughts about the process farmers need to undertake and consider to prepare their land and understand the mix with their current cattle operations to optimize all operations? I'll get you to answer the first one first, and then there's a second one about the timescale framework, which I can.
I suspect they're actually the same question there, that we have initially tested some systems where, and this goes back to the research done by McGowan and others, that when these surface seals start, they do need to be reset. And there does need to be some sort of activity to break up that soil surface and then start to repair the system. So we did test initially a system where the very fast growing cereals like sorghum, planted initially after a tillage event, protect the soil in the first instance, and then either relay cropped or intersown a deep rooted perennial system that then protects that soil into the next wet season, so that we're not just relying on the retention of that residue from the cereal crop, but we're also looking at preserving that soil surface in the build up to the wet season, when we actually found that, and similar to the research in McGowan, that in these systems, the ability to produce sufficient biomass to protect the soil is often, we just don't have the potential to do that. So protecting the soil at that build-up when those storm rains occur is most critical. Not just actually just to protect the soil, but also to capture the flush of nitrogen, the Birch effect that occurs at the beginning of the wet season. So that is one system, but I think what we want to build in this participatory action research is to develop the thought process and around farmers testing in their own systems. Because what we do know is that the soil types, especially in North Queensland, are incredibly variable. And that analogy of the desmanthus intercropped into sorghum may not be relevant in many other soil types.
Yeah, I guess that, Joe, that second part, about deep-rooted plant species, any comment on that? Not the cash crops per se, to improve deep soil conditions. Are you guys intending to look at that also at some stage or not?
So we would class desmanthus that we're working with through AgriMix as the deep-rooted legume species that will overwinter through the dry period and protect that ground, that surface at the beginning of the wet season, and also just through turnover produces deep root channels that, as the crop dies, leaves water channels.
Okay. For the next question there from Rob. Is there a scope to investigate nitrification inhibitor used for improved yields, nitrogen use efficiency, improved nitrogen loss mitigation, especially around nutrient oxide emissions and leaching, and assist in managing rainfall variability influences on nitrogen responses?
I think very much so. From the soil and cropping system component that we're looking at, I do believe that we will have the same processes that are going to improve infiltration, potentially increase deep losses, but there is a need to incorporate all of these technologies to improve nitrogen use efficiency, which is not a target of our project. However, there will be an announcement towards the end of this month of a much larger overarching program that includes components that will look at nitrogen use efficiency. And I believe that is a project that will be centered in the Orwood.
Okay, I think we're getting, if there's no more questions, quick questions, or if you get something like that, but we're 5 minutes left of this time. Any final comments from your side, Joe?
No, thanks. Just please get in contact if you'd like to collaborate in any way. I think it's a amazing opportunity we have, not just for North Queensland, but for Northern Australia in general, and the semi-arid tropics around the world, where we believe that most of the poverty over in the coming years will be in that region. So it's a critically important to Australia and the world.
Yeah. Thank you, Joe. Thank you for your presentation. I got reminded not to forget next week's seminar, which is next Tuesday. Joe, the next slide, please. It's the 9th of May, which will be presented by Dr. Hannah Siddle from QAAFI Center of Animal Science, and she will talk about why we need genetic diversity in the immune system. So another exciting seminar planned for next week. And then just want to thank you all for attending our science seminar today. And if you haven't already signed up for a seminar invitation list, please do so at the QAAFI website, Science Seminars, and or maybe click on that QR code or scan that. Okay, thank you very much, everyone. Thank you for your time, and enjoy the rest of your day. Thank you.